NASA, and NOAA. We first developed the altimeters, and at the very beginning it was quite a challenge for us to reach this accuracy, because we are speaking about typically 1 centimeter accuracy regarding the sea level local variations. And you could imagine that the type of instrument stability it means, and the nightmare it is for engineers to reach this kind of accuracy.
I can well imagine, and it is, of course, what we neglected to say, is that all of these fantastic instruments from space rely on industry to make them. So,
yes, sure.
Can you speak closer?
Yeah, and then after Topex Poseidon, we developed JSON 1 and JSON 2. And whereas the altimeters are developed in Toulouse, in our factory of Toulouse, the JSON satellites are integrated in our factory in Cannes, very close to this place where we are today. And if people are interested, they could visit it. So we recently launched JSON 2. And we are looking forward to prepare and work on JSON 3, because as all of the speakers said rightly, data continuity is really essential for ocean monitoring. But we are also, I would say, reaching a key period of time where those satellites, which were until now experimental, should become in the near future operational. What I mean is that Europe is working now on a system which is called GMES, Global Monitoring of Environment and Security.
Copernicus.
And Copernicus, for people who are more addicted on names. And the idea is to develop Sentinel satellite, which means that the satellites will be there forever. That's the idea, to ensure data continuity. Right. And 2 Sentinels, the Sentinel number 3 and Sentinel number 1, will work closely on the ocean. Sentinel number 3 is really what we call the blue Sentinel. It's related to ocean. It carries an altimeter, a radiometer to correct the effect of the atmosphere on the measurements, another optical sensor for monitoring very carefully and accurately the ocean color. And the ocean color, it's not for tourism, of course. We are speaking about ocean color. We are speaking about ocean color because it shows the phytoplankton for fisheries. It shows also pollution in the coastal areas. So this sensor would be there also in an operational manner on board of the Sentinel number 3. And another sensor would be monitoring permanently the sea surface temperature in a very accurate manner. And this is essential to better understand the thermodynamics between atmosphere and the sea, which determines a lot of the phenomena which occur within the ocean.
Can I ask you, Patrick, and I forgot to say that my neighbor over here, Jean, is also, of course, industry specific as well, or industry attached as well. But what I want to ask you is that large companies, and I'll come to you in Total, but large companies like yours need to project into the future. You have a long planning cycle on these. And of course, so do governments, especially when they have budgets that they have to get. But from a company point of view, from an industry point of view, those who make instruments, those who are going to be delivering a lot of the technology, what kinds of things are you working on now?
Let's say oceanography from space is a very important domain for us. Typically, we are spending about 30% of our research and development effort devoted to Earth observation. We devote about 30% of it to oceanography. So it's very important. And what we are working on specifically is first the next generation altimeters. Because we said together that we managed to reach an accuracy in the order of 1 centimeter about the local variation of the C8. But what we are all speaking about is the global warming.
Right.
And global warming, we can detect it, we think so, at least the experts think they can detect it by monitoring the sea level rise. But we have to know we speak about 1 millimeter, 1 or 2 millimeters per year, which means that in terms of accuracy, we need, first of all, data continuity to measure it over a long period of time. And the better we can provide the measurements, the more accurate they are, the better it is for the users.
It is extraordinary, though, that 1 centimeter measurement is not enough. It's not going to give you the necessary trends. I assume this is what you're looking at.
And therefore, we are working on new concepts for altimetry which are based on interferometry and white swath altimetry. And this is one way we hope we would improve significantly the quality of the measurements.
Thank you very much. It's absolutely fascinating. Jean-François, you're from Total, and I'd like perhaps to turn not only the scientists who very much benefit from all of this and public authorities, but there's also industry. And how does satellite data, all these services, how do they contribute to the needs of industry?
Well, it's difficult to speak for all industries.
Well, let's take at least those that you know well, like the energy field and so on.
The one where I work now. Well, we need 5 types of information. We don't need really data, we need information. We need information on the geophysical setting, geodetic and geophysical